So electromagnetism, 1860 or 70, the wonderful thing about that is if you take Maxwell's equations and you apply a little bit of calculus, it's very easy to see that the laws of electricity and the laws of magnetism combined together make what's called a wave equation, which that shows that these electric and magnetic fields oscillate, they vary. And if you have something that's a wave, and the wave then moves. And if you do the math, you find out that the speed at which these waves move is the speed of light. And so people said, wow, the speed of light comes out of those equations. And that had to be, I think, very persuasive. And of course, electromagnetism also plays a really significant role in chemistry, because after all, atoms are held together by electromagnetic forces. There's more to how atoms work. There is all the quantum mechanics stuff. But if you did not have electromagnetism, or if electromagnetism was very different, then atoms would be very different. So it plays a very big role in holding us together. So it's a staggering advance in science to have a good behavior on that. And of course, being able to tame electromagnetism is why people can hear you when you do your podcast, because through the miracles of the internet, just electricity running the computers. I mean, this is a case, if I can get on a small soapbox, where people back then said, well, why are you messing around with magnets and sparks and who cares? Well, that very fundamental digging into the laws of nature has spin-offs, and it has spin-offs. One of the big spin-offs is our entire technological society. Without being able to govern electricity, we'd still be farmers and shoemakers in cities, but we certainly would not have everything that we do. So off my soapbox, but it's really a lovely thing to show how this digging into deep, fundamental, not understood, mysterious things can 100 or 200 years later transform the world. And the type of science I do now, people often ask, well, what good is knowing about how the inside of atoms work, how the inside of quarks work? And I don't know the answer to that, but just being a little more pragmatic, if I go back, say, 100 years, where people were trying to understand how the protons and neutrons inside atoms held together, how they split, how you could combine them and so forth. This has led to nuclear power. Now, whatever you think about nuclear power, and some people like it and some people don't, but it is powerful. It will generate energy for humanity. And it may be that is the path that we take as we move away from digging fossil fuels out of the ground. Humanity is going to need power no matter what. Nobody is going to go back to the way things were in the 1700s. And one enormous source of energy that is there for us to take, if we so choose, is the modification of the nucleus of atoms. Seem to have absolutely nothing to do with anything, and yet it provides humanity with an opportunity, which of course requires that we think carefully of how we do that, and if we want to, but it gives us something that we didn't have before.